Howdy, this is Dr. Stacy Lyle. This is a video to discuss the fall 2017 Remote Sensing for Geographical Analysis project paper. So I've made this due on December 14th, which is like the last day of exams. So this should give you a plenty time. We should be wrapping up all of our coursework and it'll allow you to finish up your work, then, finish up this project. So you need to produce a paper, which will have, I'll have an example. I'll show you what I'm looking for. It should be 3 to 20 pages. The 3 pages might be that you're collaborating with somebody or you're describing what you'll do, and I'll have more details on that. But we're going to follow basically the guidelines of conference proceedings. What I highly encourage my students to do is to submit their papers to be published so that you can add this to your resume or CV. So you look at these different proceedings, there's others you can find on your own, but there are conferences that might be around the US or international that look for student graduate papers to be put together. So I encourage you to do that. So the project is basically going to be a research project on remote sensing. You have two options. One is going to be a project of your choice, and then the other one is a project that I am outlining that you can work on very easily and get it done. So they're intended to be individual assignments, but I'll consider a group of one or two, three people that want to put a substantial project forward working together. I have two that are working together that's going to fly some drones and look at some methane leaks and analysis. But you can then take and try to get a paper doing some substantial analysis and you write it in the state your problem, state the method you use, state the results kind of format. All right. And they're supposed to be above and beyond our laboratory exercises, but they can use the laboratory exercises to try to work from. You want to make sure that you have all the rights to the data that you're using because I want this to be public. For our projects, we'll be putting them on our ArcGIS Online account. We'll use a story map to basically publish our paper at the same time. So again, try to look at potential conferences you can publish your paper at. I have this how to write scientific or how to write and publish a scientific paper by Robert Day. It's a great book if you're looking to improve your writing. I'll have some excerpts from that to help you. But if you can find one of these used, it's a good book to look at. All right, so let's look at the projects. Basically, you have two options. You can come to me with your own individual creative project that you want to do. I need to know by maybe the 20th within 5 days what you want to do so I could give you some guidelines and help just to make sure your project works. If you go with the project that we are looking at suggesting that you do, it's a UAV, which is unmanned aerial or aircraft vehicle, or a drone. People don't like using the word drone. Data processing and image analysis project. So basically what we're going to do is we're going to capture some images over a certain area, and then we're going to test how well those images work. And where we use and fly those, we will test the 3D elevation in the NDVI models that are collected. Now, NDVI, Vegetation Index, we'll be covering this in our next lab, so you'll learn more about how to do that and how that happens. But what's nice about these drones is that they produce a product that we can generate an elevation model. And what we're going to do is take that elevation model and subtract it from another elevation model. So you have a digital surface model or a digital elevation model, and we have some existing surface models, elevation models. We're going to use in Brazos County here, for example. You could subtract the two and make a new data set to tell how well it works. The same can be done with the NDVI. So you'll obtain some UAV data, or I'll supply some to you. You'll process it with a demo licensing online and get that 3D model or that NDVI model. Then you'll use Envy or ArcGIS to do the verification or subtracting the two documents. And then you'll define somewhat of an automated process like a model builder, how you see this happening. So the results will be your captured data, your verified data, the automated process that you see this being done, and then an example where you took and processed that data and got those. And I'll have several tutorials and videos and data all set up. It'll be your own project, but you know how well you do it and how you produce it will look really good. And understanding how to do this has a huge advantage to the industry and to you. You'll form your conclusions. You'll say, well, was this a good use of remote sensing? Anytime you do a research project, you want to say, is this a good use of that technology, or could I've done it another way? You want to see where it can be applied. Can it be applied to atmospheric problems or ocean problems, cryosphere or land problems, or anything in the geosciences? Where can it be applied? And would it work for close range remote sensing? Like if you were taking cracks in bridge structures, could you use the same kind of technology? And then testing these against maybe satellite observations. So it's good to see this, and I'll give a good example of this as I show you how to do it. Okay, so your project write-up, you'll have an intro section, a method section, a results section, a discussion section, can be combined with a conclusion section, and then any references that you have. You look back towards my dissertation. My dissertation was written where they were like a combination of three papers published in peer review of mine. They followed this basic outline, and this is what you'll do. All right, so if you choose to write your own, make sure you get back to me on the 20th. If you want to work on my project, let me know, and I will start getting that data out to you this week and next week so we can complete it by the timeline, which is at the end of final examinations. All right, good luck.